Hello everyone, how to solve this problem for the values of k if we have 2 to the power of k plus 4 to the power of k plus 8 to the power of k equals to 39, and we solve this problem for all real values of k. So it means that we just solve this problem for only real values of k. So here the very first thing we are going to do is first we need to rewrite this equation as in this form. So this is 2 to the power of k, we write as it is, plus this is 4, we write this 4 into the form of prime factors, and its prime factors are 2 squared and its whole power k, plus we write this 8 as 2 cubed and its whole power is k is equals to 39. And further in the next step we use here the nice exponential law. You know about that. If we have a to the power of m to the power of n is equals to here we just need to interchange these two exponents, and when we interchange these two exponents it does not affect our final answer, and it is equals to a to the power of m multiplied by n. It means that in the exponents, if you can interchange the exponents, likewise here if we interchange these two exponents, then it cannot be affected our final answer. So it is possible that you can interchange the exponents. So here we need to just interchange these two exponents and these two exponents as well, so that we write it as 2 to the power of k, plus here we interchange these two exponents, it will becomes 2 to the power of k and its whole square, plus here we again interchange the exponents and it will becomes 2 to the power of k and its whole cubed is equals to 39. So you see here the base of each of these terms is 2 to the power of k, so that now we convert this exponential equation into the simple cubic polynomial, so that for this we just take here our x is equals to 2 to the power of k. So when you choose x equals 2 to the power of k, our above equation is written as this will becomes here x plus x square plus this is x cubed is equals to 39. And now this is a cubic equation with x variable, so that here we need to make the factors of this equation to find the values, to find the real values of x. Okay, so here we have this is x plus x square plus x cubed, and here we write this 39 as 27 plus 9 plus 3. We just break this 39 as in 3 values, because in the left hand side we have these 3 values, so that's why we break these values in this form, in which we can write one value into the cubic form, the second one is into the squared form, and third one is into the one exponent. So here we break these values in this way. So now here we need to move all of these values into the left hand side, and we make the pair of x with 3. This is positive 3. When we move it into the left hand side, it will becomes negative 3, plus this is x square, and here we make the pair of x square with 9. This is positive 9 becomes negative 9. This is x cubed, and we make the pair of x cubed with this 27, and this whole equation is equals to 0. So further here in the next step we rewrite this equation as this is x minus 3 times plus this is x square minus we write this 9 as 3 square, plus we write here this is x cubed minus 27, we write this 27 as 3 cubed, and this whole equation is equals to 0. And further in the next step we need to use here the nice algebraic formula. You know about that. If we have a square minus b square is equals to a minus b times of a plus b, and in the same pattern we use here the cubic formula. It is a cubed minus b cubed is equals to a minus b times of a square plus ab plus b square. So in the first factor we apply the square identity or square formula, the second factor we apply the cubic formula. So here first we need to use here the square formula on this term. So after applying this formula, it will be written as this is x minus 3 plus this will be written as x minus 3 times of x plus 3, and plus when we apply the cubic formula on here, it will be written as First you have a minus b, it will becomes x minus 3 into this is x square plus ab. Here our a is x, b is 3 plus b square, so b is 3 square, and this whole equation is equals to 0. And in the next step, you see here each of these three terms involve x minus 3, so that we will take common x minus 3 from here and we get the remaining values are. From here we get 1 plus, from here we get x plus 3, and plus from here now we get this value, it will becomes x square plus this is 3 times of x becomes 3x, and 3 square becomes 9, and this whole equation is equals to 0. And further in the next step we need more simplifications, and it will be written as x minus 3 times of this is 1 plus 3 becomes here 4, and plus this is x plus 3x becomes 4x, and plus this is x square, and we have this is plus 9, and this whole equation is equals to 0. So further we divide this equation into the two cases. The first case is we write x minus 3 equals to 0, and the second case is we write and also we write this into the standard form. So it is x square plus 4x plus this is 4 plus 9 becomes 13, and this whole equation is equals to 0. So here we need to focus on this term, and from here we move this minus 3 to the right hand side, and we easily get the value of x is equals to 3. So this is the first root of the given equation, and now this is the real root. So now here further in the next step we need to check that is this quadratic equation has real root or not. So that here we use the discriminant formula to check that is this equation has a real root or complex. So for this we first need to write the coefficients of this equation, and its coefficients are a is equals to 1, b is equals to 4, and c is equals to 13. So here we know about that discriminant formula is denoted by delta equals to b square minus 4 times of ac, and we know that if our delta is greater than 0 then or equals to 0, then this means that this has real roots, and if this delta is less than 0, this means that it has complex roots. So that here we need to substitute the values of a, b, and c here, and we check its behavior. So this will becomes delta equals to b square, so b is 4 square minus 4 times of a is 1, c is 13. So we will get here 4 square becomes 16 minus 4 times of 13 equals to 4 3s are 12. We write 2 and carry 1, 4 1s are 4 plus 1 becomes 5. 4 times 13 becomes here 52. So this will be written as 16 minus 52 becomes here minus 39. So this is the value of delta, and this you clearly see here this is negative value. It means that this is less than 0. So if this is less than 0, this means that it has complex roots. If it has complex roots, or in other words you just say that it does not have a real roots. So if this value does not have a real root, so that we just rejected this case because it has no real roots. So here we just proceed this case only, and in this case we have the value of x is equals to 3. We will just copy down here x equals to 3, and now we back substitute the value of x, and you see here in the start of the problem we will take here x equals 2 to the power of k. So after substituting this value back value here, and we get the values of k. So this is 2 to the power of k is equals to 3. So here we need to find the value of k, so that's why we just take the log on both of the sides, and when we take log it will be written as log of 2 to the power of k is equals to log of 3. And here in the next step we need to move the exponent k into the front of this log, and it will becomes here k times of log 2 is equals to log of 3. And further we move this log of 2 to the right hand side, and it will becomes here k equals to log of 3 divided by log of 2. And finally this implies that we have k is equals to log of 3 with base 2. So this is the final real value of k, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.